welcome to Mathematics Form 3. We are looking at quadratic equations and expression. Previously, we were having examples of expressions, for example, x squared plus 6x plus 9, and we could factor them to get this as x plus 3 is equals to x plus 3 squared as the factor of this quadratic expression. Now, we give a name to this. We call them perfect squares. These are quadratics that you can simplify to create a square of two other brackets. And there was a formula that we were using that was saying that if b all over 2 squared is equals to a times c, then that quadratic expression becomes a perfect square. Let us try for example here. You take the value of b, which is 6 all over 2 squared. Is it equal to 1 times 9? If the answer is yes, then this is a perfect square and we can proceed to write it as this. So this will give us 3 squared, which is 9, which is equals to 1 times 9, which is 9. Therefore, since b all over 2 squared is equals to a times c for this case, then this quadratic expression is a perfect square. We also came up with a shortcut that many of us, we also need to train ourselves to use it, where you have x squared plus 6x plus 9. You do not need to go through the whole process. So on this side, I'm going to do the wrong process. Then on the other side, I'll give you the shortcut of getting that answer direct once you confirm that indeed this is a perfect square. So the wrong process involves identifying what is A, what is B, and what is C. From there, you talk of product of two numbers to give you A times C, which is 9, sum of two numbers to give you 6. This is something that we learned back in Form 2. From there, the two numbers are positive 3 and another positive 3. You bring them back to your quadratic expression as x squared. We eliminate this b. We substitute with these two numbers. So the first one will be 3x plus 3x, then plus 9. At this level, we talk of factorizing by grouping. I group the first two. What is common? X is common. So I have x plus 3. The other two, I group them. Positive 3 is common. Then I have this as the x plus 3. Therefore, since these are the same, I am still correct, so I can proceed. Those numbers that are outside the brackets, we group them together. Then I pick one of these which is identical as x plus 3. And as you can see, we are ending up with x plus 3 times x plus 3, which is just x plus 3 squared. That's a very long process. If I know that this quadratic expression is a perfect square, there is a shortcut of doing that question. And this is the shortcut. You first write it again. X squared plus 6x plus 9. Then you square root the first number. So x squared, you square root that to give you x. Take the sign of b, which is positive, and square root the last number, which will give you 3. Then cross them in a bracket, and then you square them. So compare between those two stages. Definitely, I would prefer this shorter one. It saves me a lot of stress in even thinking of the numbers. But now, is it possible to make any quadratic to become a perfect square? Some quadratics are not perfect squares. And today I want us to learn how to make quadratics become perfect squares. Therefore, it's known as completing the square. So we are completing it so that it can become a perfect square. Then we can use the shortcut that we have talked of. Let me take an example. Consider the following. A, x squared minus 16x plus dash will make it a perfect square. Now we go back to our formula in the solution. we say that for a perfect square, b all over 2 squared is equals to a times c. Therefore, we can see that our a is equals to 1, our b is negative 16, this one. Remember, b is the number that multiplies x when the power is 1. Therefore, we are looking for c. So I substitute it here. I'm going to have negative 16 over 2, because it's b all over 2 squared is equals to 1 times c. But you know 1 times c is just c. Therefore, this will give us 4 squared, because this will be 1, not 4 squared, by 2, 1 by 2, negative 8. So negative 8 squared is 64, because we know that negative times negative is positive. So 64 is equals to c. Therefore, what number must I fill here so that this becomes a perfect square? I should put positive 64. That's just one example. Let me try another one that has a missing value. There's this question that says x squared plus dash plus 16. What number must I complete it with here to make it a perfect square? So it is very simple in the solution. First, we come and check what we have. We know that the formula is b all over 2 squared is equals to a times c, or ac. So a is equals to 1, b is missing, and c is equals to 16. Therefore, I shall have this as b all over 2 squared, because I don't know what is b, is equals to, what is 16 times 1? 16. Therefore, I square root both sides, so that I remove this square. You remove a square by square root in both sides. So the square and the square root cancel. We remain with b all over 2 is equals to, this is what? 4. Therefore, cross multiply, and we have b is equals to 8. Therefore, for this number to be a perfect square, I must put an 8 there to make it a perfect square. Therefore, next time, we are going to learn something new about how to use now these perfect squares to solve quadratic equations. We have just been looking at quadratic expressions, not equations. So we shall be using this knowledge on completing squares to try and solve some questions on quadratic equations. Remember, for a perfect square, then b all over 2 squared should be equals to ac. But as I wind up, I would want us to solve this. Now that we have made them perfect squares, let me pick one. A was x squared minus 16x plus 64. Let us try to factorize it. Now that using the short method, we have said square root the first number, which is now x, take the sign of b minus square root the last number, which is square root of 64. Correct? 8. Then you put a bracket and put a square. That's how we do it. Let me take the other one. Now that I've made sure that it's a perfect square, b is x squared plus 8 plus 16. And remember, here we had forgotten it should be 8x. It cannot have a b without an x. So 8x plus 16. Square root the first number, x. Take the sign of b. Square root the last number, 4. Put a bracket, and then you write it as a square. So that is all for today. Let us meet next time. Do more practice. It might seem as if it's a very simple thing, but practice more, especially making numbers to become perfect squares, something that we call completing the square. So thank you for watching. Let us meet next time.